Students, there will be many occasions when you want to solve a particular question in as much as less time as possible. This is the time where your shortcut techniques, the tricks will come very handy. Now, not always shortcut techniques are available, but whenever they are available, you make sure that you make use of them to solve the questions as quickly as possible and as accurately as possible. Now, when we talk about derivatives, there are some shortcut techniques available to solve some of the questions in derivatives. So students, I'm going to discuss those shortcut techniques with you all. I welcome you all to this channel, Pankaj Lade. Let's begin with today's shortcut technique. There is one part called logarithmic differentiation in derivatives. We are going to understand what that shortcut technique is. Let's see. Now you remember, if I write y is equal to f of x raised to g of x, here the base as well as the index, both of them are functions of x. They are both variables. Now when such a situation arises, we make use of the logarithmic differentiation. Now the conventional way is take log on both end sides and then you use the concepts of logarithms and then you differentiate the particular question. Now to understand the conventional method, I have already posted a video on my channel. Make sure that you subscribe to that channel, you watch the video, like it and share it as much as possible. Now here we are going to understand what is the shortcut technique. Now students, first thing, you need to understand the base and the index. You need to know what is the base and what is the index, because our shortcut technique is entirely depending on identification of the base and the index. Now look at the technique, what it is. If you want to get the derivative of such kind of a function where the base as well as the index, both of them are functions of x, use this. Y is equal to, keep the base constant and the index as a variable. Keep the base constant and the index as a variable and to differentiate the function. Then write a plus sign, and this time you take the base as the variable and the index as a constant. So this is the technique that you should be applying. So at this moment you might not be able to get what the technique is. Let me take an example and then you will come to know what I have written over here. I am writing here base is constant, index is variable. Base is variable, index is constant. Let's take a very powerful example, a very important example that you have to remember like a formula. So if I write y is equal to x raised to x, now this, people, you remember it like a formula. Once I get the derivative of this function, you should remember it like the back of your hand. Means whenever I ask you what is the derivative of x raised to x, very quickly without differentiating you should be knowing the answer for this. So let's understand how the technique is applicable over here. So the technique is telling me keep the base constant, So I know this x is a base, isn't it? This x is a base and this x is an index. So the technique is telling me that you keep the base constant. So dy by dx becomes equal to, so I'm treating x like a constant. So you can read it like a, it's a constant, so you read it like a. So it becomes a raised to x. I am taking index as a variable, so it is a raised to x. So what is derivative of a raised to x? The derivative of a raised to x is a raised to x log a, isn't it? The derivative of a raised to x, we know that it is a raised to x log a. So here I'll write a raised to x log a. But what is in place of a? In place of a is x, isn't it? We have taken this x as a. So my answer is going to be a raised to x. So x raised to x log a, log x, isn't it? So that was the first part of the technique. Then you put a plus sign, and now the technique is telling me you keep the base as a variable and index as a constant. So base is now going to be taken as a variable and the index will be taken as constant. So this time now base is variable. So you read it like x only. And now you take the index as a constant. So you can read this like a, or you can read this like n. So it becomes x raised to n. So what is derivative of x raised to n? The derivative of x raised to n is n x raised to n minus 1. So here n x raised to n minus 1. But what is in place of n? There is x. So I'll write x into x raised to x minus 1. X raised to n is n x raised to n minus 1, but n is x, so I have written it x over there. Now if you remember, this is x raised to 1 and there is a law of indices property, a raised to m into a raised to n is a raised to m plus n. So if I use it here, x raised to x log x plus this power is 1, this power is x minus 1, so the powers will get added and you will get x raised to 1 plus x minus 1. That is x, and you can simply take out x raised to x common and your answer comes 1 plus log x. Did you observe? These are all my simplification steps. I have got my answer in the very first line itself. That means this technique is so powerful that you will end up with the answer in just one line. If you don't believe me, I'll take one more example. So that was the answer for x raised to x. Let's take one more example to understand this. I hope you have already noted this down. Students, make sure that whenever you are watching these videos, you are also noting down the things in your notebook. See, memory works in a very different way. If you involve your senses into your learning process, your learning becomes very very deep. So that is why you try to involve as many senses as you can. So whenever I am asking you to write down some things, you make sure that you note down the things in your notebook. Let's take one more example. So if I now give you y is equal to, say, tan x raised to x, observe how I can get the answer in just one step. So students, dy by dx is going to be equal to, what is the technique telling me? It is telling me you keep the base constant. Keep the base constant. So you treat tan x like a constant. You see the tan x term as a constant. You can call it as a. So it is a raised to x. What is derivative of a raised to x? Derivative of a raised to x is a raised to x into log a. So here the derivative will be a raised to x into log a, where a is tan x, isn't it? So that's the first part. Then take plus sign. So write the plus sign, and this time you keep the base as the variable and index as the constant. So x is a constant now and tan x is a variable. So base is a variable, index is a constant. Index is a constant. So what is derivative of x raised to n? It is n x raised to n minus 1. So I write n into x raised to n minus 1. X minus 1. But students, is it x raised to n? It is not x raised to n. It is tan x raised to n. So again you need to make use of the chain rule and you need to differentiate tan x, and the derivative is going to be sec square x, isn't it? So now if you want to simplify this, look at the answer, how simple it is. So the answer is going to be tan x raised to x into log of tan x, then plus x. You can write this, observe here, it is a raised to m minus n. Your law of indices has to be very thorough. You need to know your law of indices very properly. So a raised to m minus n, if you remember, it is given as a raised to m upon a raised to n. So tan x raised to x minus 1 can be written as tan x raised to x upon tan x, isn't it, into sec square x. So from here you can definitely take out the tan x raised to x, this term common, and inside the bracket what is left, the first term is left is log of tan x, and the second term is x sec square x and tan x, x sec square x and tan x. Now at the most what can happen is you will need to simplify tan x and sec square x using their basic trigonometric formulas. For instance, you can write tan as sine upon cos, and send the cos up, So what will happen here? Let's try and understand what will quickly happen here. So this tan x is sine x upon cos x. So the cos goes up, cos into sec becomes 1. So this is sec x upon sine x, or this can be also simplified as x upon sin x into cos x. Now you need to check for your options. That is all you need to simplify at the end, if it is at all required. If it is required, then you simplify. Otherwise, did you observe? I just need one step to get my answer. These two steps are nothing but the simplification steps. So this is how the technique is powerfully involved while getting answers of logarithmic differentiation. Students, I hope you must have definitely understood what the shortcut technique is. Make sure that you take different varieties of questions to apply this technique. Apply this technique as much as possible. Only then you will come to know what this technique is. So students, I am thanking you all for watching this video. You all have a great day ahead. Thank you so much.